Good afternoon, everybody. Thank you for staying and not going to see the AWS presentation. I must admit, whenever I looked at it, I thought I quite actually like to be there. But unfortunately, I have to stand here and do this. So hopefully, I can make it interesting for you. My name's Gavin Walker. Horrible picture, sorry. I'm the Director of Service Design and Transition for NATS. That's ITIL speak for Director of Programs and Engineering. I've been in NATS for 33 years, so I've been there forever. But I now head up all the programs in engineering and the transformation program we're going to go through. I thought about trying to explain what NATS does. We're very much a hidden part of the critical national infrastructure, safety critical air traffic control. So I've got 2 minutes and 8 seconds of a video which will actually show a lot more about what NATS does than I could ever explain in that length of time. So I'll just start that now, hopefully. Maybe. So all that is made up of real data over a 24-hour period of what NATS does. I'm going to top and tail this presentation and focus really very much on the applied innovation side of things. So I'm very much a pragmatist in actually delivering. And I want to say I always get motivated by getting things done and actually making things happen. I'm accountable for the largest transformation program within NATS. We're spending over £1 billion over the last 5 years and the next 3 years to actually transform the business and how we provide traffic management. What you saw there is the 24-hour traffic that we actually, every one of those little dots and those little trails of light is a real aircraft that actually we have to control, we have to keep separate and actually deliver on time with no delays whatsoever. The transformation program, it will actually change the way in which we do that fundamentally from the ground up through technology to deliver that. But a key part of that, we want to adopt that technology much, much faster. A key part of that, once you deliver the technology, is the transition from what we currently do, which is clearly very, very complicated, and we deliver an excellent service, to something that will actually be the next progression. The point of transition from going from what the old services are to the new services, that transition in the program is a really critical point in time. Unlike railways or other infrastructures, we cannot stop air traffic and close the skies. So we have to perform and transform from what we did before and transition to the new seamlessly so that you don't see that with no delay. And actually, that point is a very critical point. The people who make all of that work and move those aircraft are the air traffic controllers, the people who sit in front of the screens. They have a license which is personal to them. It's not a NATS license. It's their license to actually control those air traffic. Change is a big part of what we have to do, and actually getting controllers confident to go from what they were doing before and transitioning to what they have to do in the future is a key point and is the real key part of success for any program. A way in which we measure that, of how confident the controllers are, is through situational awareness. And it's a key point of how they actually feel confident in what they do. So if their situational awareness is high, then they're confident they can control air traffic. If their situational awareness is low, then that impacts them and how they can actually do it. Being able to transition faster into these programs and be much more understanding of how well that's going to go is a key thing that I want to have whenever we actually transform these services over the next few years. Understanding the situational awareness, therefore, is very, very key. And it means an awful lot to different people. We've discovered that, and in the past, then it's been not that well understood, and it's been very much at the point of transition, we make a decision we're going to have to go ahead or going to revert back. It's a very key thing to understand. In the past, we've relied on self-assessment from the controllers to actually do it, a very subjective view of how that self-assessment, of how that situation will happen. Now, it stands for an awful lot. It really reflects what those people want to do and how they feel, but actually that alone is a very, very high-risk strategy whenever you're doing so much transformation change and actually the cost of doing that. As a director of programs, I'm driven by this is what we need to deliver by when. I have to report to the board, but it's a safety critical environment we work within. There's a huge amount of pressure of we're spending all this money, you have to implement it here, but safety is our paramount within NATS, and we cannot put at risk safety at all. So that balance between how hard do you push to get things in to deliver the benefits and do the change and transform, to actually it's not the right time, we need to do more, we need to take more time to do that to get the confidence. That measure of situational awareness of the end customer, so applied innovation is putting the customer, the end user first, that information of how they feel and that situational awareness is really, really important. So relying on self-assessment and a very subjective view is certainly okay. And that's what we've used in the past, and we've had a lot of success. But there must be another way, and we need a more objective way to supplement that subjective view so that we can have more confidence that what we're doing is right. If it's not correct and it may impact safety, then we can back off and we can change our tack and actually look at something else. So having a more objective view to supplement that the subjective view is a key thing. NATS, you'll hear shortly from Priscilla, like NATS is very much a siloed organization in the past, and there's a lot of culture change going on. I think it was Albert Einstein that said that the definition of insanity is that if you keep on doing the same thing time and time again, expecting it to change, then you're insane. Well, I think NATS has done an awful lot in this in the past, where actually when you look at how do we transition and how do we get that level of confidence about what we're doing is the right thing and that the end outcome is going to be the right answer. We've been doing the same things over and over and over again in very different and siloed views. That needed a change, so we need to do something different. So leveraging an external perspective on how we can actually tackle this is what I wanted to do and to drive that. So I'll hand over to Priscilla to take you through what we actually did.
Thanks, Gavin. So the AIE, the Applied Innovation Exchange in Capgemini, we're designed to solve complex problems with emerging technology. And I'll be honest, I don't know how much more complicated it can get, like a project like this, where we're measuring situational awareness. And I think we can all relate, right? We have to transition to adopting technology. And the problem that Gavin has, I feel, is so much harder because we're talking about airspace and we're talking about safety. So very exciting, really opportunity to lead. And I was reflecting. I'm like, how have we come across this opportunity? And I think there's two things in this. One is that we have a client that has identified an opportunity where technology can really make a difference and invest in it. And that's a bold decision. Second is that we're not afraid to try a different approach, right? Back to not doing the same thing over and over again. And that allowed us to lead into a different journey with NATS. And that journey, I'll be honest, I want to reflect that it's been something that's been worked on in the organization for some time, situational awareness. It's in silos. A lot of the thinking is within different functions. And I think we can relate again, how do we really deliver value and improvements across the business over the long term when you can't unlock those opportunities? So how do we tell a compelling story that everyone can be invested in across the organization? I think part of that is key ingredients from NATS. So a vision and an ambition, not the lack of imagination of what the future of airspace might require and the kind of transitions and transformations that are ahead of us. And then the other thing is deep expertise. They are the experts. Air traffic controllers do this as a living and are licensed. This is their livelihood. So we do trust that expertise. And we're very fortunate to have an engaging workforce that is ready for change. So what did we try to provide from a Capgemini perspective? Is we have this opportunity to look across different industries like automotive, manufacturing, to find other insights that could apply. Because I'm sure you're listening to the story, I'm sure you're going to say, how could we use this in other industries? We have a large ecosystem of partners that we rely on. We don't have to build everything ourselves. A lot of things are readily available. And then the third thing I'd say is a really diverse team, a multidisciplinary team that reflects user research, designers, academic research, biometric engineers, AI, machine learning experts, a real diverse group that is driven with a single purpose to improve situational awareness. So what is situational awareness? Gavin kind of touched upon it. It's kind of the understanding the environment. So imagine you're an air traffic controller. What is that environment? That is a number of aircraft. That is weather. That is flight paths, all in 3D. And being able to understand the meaning of that today and project into the future so you can make some decisions around it. This is not easy. This simple equation that you see here is actually a framework called the SART model. It breaks down situational awareness in these constructs. And these constructs is understanding, attentional demand, and attentional supply. And if you look at these kind of subcomponents, there are specific nuances in this equation. And we worked to unpack that into specific data sets that could be representative of any one of these attributes. Combined with, as Gavin mentioned, a subjective understanding of how they feel. So what did we do? A set of data-driven and technology-driven experiments. So you'll see on the left side an air traffic controller's environment, and you'll see on the right side experiments we did in our lab around understanding the feasibility of extracting this data from the systems that NATS already has, right? Their workload, session data, then objective data in terms of physiologically their response, and then you have the subjective data. So let me show you a quick video of some of those experiments firsthand. So you'll see here a Fitbit where we extracted live heart rate variability data, thermal imaging cameras, which again linked to research show that has a bearing on alertness. And this is custom AI models to detect blink rate, yawn detection, and also posture. And you can see there's also a game that we created that helps us adjust the level of complexity over time. And this is, again, just to give us a sense of feasibility of what can be done, extracted, what value of the data is there, how viable is it, and then the desirability. It's actually really just a camera. That's it. Okay, so this brings it all together, is that one data set's not good enough. If we're gonna really understand an individual's situational awareness, don't know if it's me, situational individual awareness, then we need to look at all components of both system, objective, and subjective data. So I'll go back to industry leading just for a moment. I think we all are very excited about the possibility of technology. I think what the stuff I just showed you probably isn't something beyond the imagination. But can you imagine how humans are expected to interact with the machines? How are we supposed to respond? What is our level of adoption? How fast and how quickly should we transition? And that is probably a bigger bearing and question for all of us in the next 10 years. And the approach that we've taken of using data and a human-centered approach, I think, is one of the most important steps into the next 10 years of how we interact with machines. I'm going to pass it back to Gavin to go a little bit deeper in the collaboration and impact of NATS.
So connecting the dots and fostering the collaboration. So what happened whenever with what went on with the experiments and actually the insights that we got really helped us to actually join what does this actually mean. And one of the great insights that we actually got was that we could link also situational awareness and how the controllers felt from situational awareness to their well-being, and how that actually can improve their well-being. The controllers are a very unusual bunch of people in that they come in and they're very proud of what they do, but actually they are controllers first and then they work for NATS second. What we actually were able to do and understand was that actually through the work that we looked at was actually they're wanting to be more involved, and actually that involvement and how that reflected actually through their targeting their well-being as a mechanism to say that actually what we're doing here from a program perspective, from actually investing this analysis and understanding how you really work, and your participation in that is linked directly to your how you can the measure of situation awareness, and that how they can actually feel better about what they're doing. They definitely feel that actually whenever NATS do change, it's being done to them rather than being participative of it. And if this actually is anticipated as this is part of them helping them to do their job much, much better, and it's demonstrated and comes out in how that situational awareness improves, and you can tangibly see that through subjective and objective means, then that's a real positive from what we got. I've talked about the well-being as a motivation. Empathy in a complex operation. So how did the team help really to do this? We talked about I had to do something different and leverage. All the things that Priscilla and the team showed was the experiments they did. We've done that. We've done some of them to some shape or form in the past in NATS. But what the AIE team brought to this whole thing was actually a real level of understanding, and demonstrated they understood this complex way of working very, very quickly and very, very well. So there was a real empathy from the team of actually understanding and getting close to the controllers to actually understand that. If you heard from the keynote speech this morning about the bionic arms, that a key thing and the key difference was that they spent a lot of time in the homes of the people to see how that actually worked. The team spent a lot of time with the controllers in the environment to actually understand that, and then we're able to replay that back into the experiments. It's always a very nervous time as me as in my role, whenever we start to embark upon these type of experiments, is whenever you roll in some consultants, in brackets, and we've all been there, and they start to talk about this, they want to do that, want to do this, and they completely ignore what the actual users are actually saying. This empathy, it was really a key part of what actually made a difference to actually cut across and bring together a lot of the silos that actually existed in NATS, where a lot of the understanding already had been, plus with all of the applied knowledge from the really clever team that actually were there. Bringing that together was the real strength of actually getting to this insight of where we are. And that for me, looking for something different to come in from the outside to actually make that real change was really, really priceless. Although there obviously is a price always to that. Just get it in there. Let's bring it down, make it real here. Don't get this for free. Unless, Chris, you want to do that for me for the next one. But if you're looking for one bit of insight of that how these things together, and look at, if you've been to some of the presentations, that's the key one thing for me, was that actually we put the users and the controllers first and foremost in this whole thing. The approach worked really closely with them. There's a demonstration of a very complex business of NATS that was understood very, very quickly. And then the professionalism and the way that was talked, you still have to challenge, but you can't challenge without bringing the people along. And that whole navigating that whole landscape was the real difference. Now, it was only experiments, and this was kind of a proof of concept to get there. We've heard also about failing fast as well. The next stages, hopefully, is the next one. The next steps are to actually take this up into scale and to actually identify a number of different experiments, to do that in a very concentrated way in our control center in Prestwick, to actually then really, really drive hard the objective data and testing all the different types of biometrics and see which ones actually yield the best results. The other key thing that will be different to what we've done before is that when those experiments are actually done, then we will be able to draw analysis and conclusions between the subjective data and the objective data there very, very quickly to prove or disprove actually these biometrics are actually working. In the past, we've always done it and in the various guises of in silos, but never joined up and never seen the whole picture. And we've never been able to categorically prove one way or the other. I really don't care about the answer, to be honest. I just want to make sure that whatever we believe we are doing, we can prove whether it's working and the value that it's actually adding. If it's not adding any value, then bin it and move on. And I can't wait to actually be able to say, we've already done that, not looking at that again, don't care what your idea says, come up with something else and let's look at it. Because that's insanity if you keep on going round and round and round again. And I'm definitely not insane. So hopefully maybe in the future, whenever we're going to be doing that through November, December time with the pilot. The key thing for me is the big transformations are all next year. I want to be able to get as much data before those transitions. So leading up to those transitions, we're very confident about what the baseline is. So through the training periods, then I'll be confident what the baseline is. And then during the transition, I'll know whether the service is under more pressure or less pressure. And then post the transition, I will know how well the changes are actually working or not working, because the whole idea of doing all this technology and transformation is to actually improve the business. So hopefully maybe I will be able to come back and actually tell you all the results, and hopefully that will be in a positive way in the future. So with that, I'd like to say thank you very much. And if there are any questions, I think we've got a few minutes. I can definitely take some questions. So as clear as mud. Okay. 1, 2, 3. Any more? No? All right. Well, thank you. Oh, yeah. Sorry. There we go. Before the wire, I was almost going to say sold.
High level. Would you be able to review any of the? Just for this. Yeah. That's been very much high level overview. Would you be able to reveal any details of the transformation? What that's actually about? How is it going to improve the controller's life in any specific?
Yeah, so there's a number of ways the transformation is going to improve. So the use of technology for our air traffic control centers, then we will have one common platform built on modern infrastructure. It's a very old infrastructure that the sort of flight plans and the planes you see flying around, we are at capacity. To actually improve that capacity, because the air traffic growth is increasing 8% year on year, we have to do something different. And so it's a fundamental root and branch from the very bottom, how we actually deliver the technology we're using and building that. From a controller's perspective, what does that mean for them? The type of technology they will have will improve their safety. There will be a lot more conformance tools. So whenever a controller has a headset on and a mic, They press a button to talk to the aircraft. It goes down, out through an antenna, up to the aircraft, into the headphones of the pilot. So when they say climb to a flight level or turn such and such a way, some of our systems do conformance checking. So it knows what the controller types that in. That's what I told the aircraft. The pilot listens, hears it, and then does it. If the system sees that the pilot didn't do what was said, then it puts up a box and says that that's a problem. So there's lots of safety. And now we have that in lots of different areas, but not consistently across the whole of the service. The other thing is about prediction, where we use complex algorithms to check where aircraft are. So if you ask an aircraft to turn right or left or to climb or descend, then it looks 18 minutes ahead at the moment in certain parts of our operation, and it will provide a conflict detection on that. In the future, with the new systems, when you decide you're flying from Heathrow to Glasgow, and the aircraft's climbing, and the controller says, I'm going to move you to there, it will now work out where you are, because that actually, it'll give a number of different options. But it will say, actually, delaying that aircraft here will miss a very big delay at the back, and it'll improve efficiency all the way through that. All of that is taking away effort from the controller and hopefully improving their situation awareness as well. All right, okay. Cool.
Thank you very much.
Cheers.